solving inequalities and also giving some review of interval notation in this video. So if we want to solve and graph 3 minus 2x is less than or equal to 11, then an inequality is solved in the same manner as equations, but when we graph on the number line and also use interval notation, we see that we do not just have a single solution, but we have an infinite set of numbers that are in our solution. So we're going to start by subtracting 3 from both sides, getting negative 2x is less than or equal to 8. And we have negative 2x, which means that we need to divide by a negative. And an easy way to think about dividing both sides of an inequality or multiplying both sides of an inequality by a negative, it's kind of like throwing the Uno reverse card. So the negative 2's cancel here, but instead of it being less than or equal to now, the inequality sign flips to greater than or equal to negative 4 because we have divided by a negative. So keep that in mind. Anytime we multiply or divide by a negative, flip the sign. So our answers are, and if you'll think of that every time you see the variable x, think of the phrase our answers, because there are infinitely many, are all greater than or equal to negative 4. So if we put this on a number line, so there's 0, there's negative 4, we'll put negative 2, put negative 6. So normally in Algebra 1 and Algebra 2, when we put this on the number line, because of the or equal to, it would have been a closed circle. And then from there, we're going to shade everything to the right. Why? Because our answers are greater than negative 4. Now, if we want to think about this in terms of interval notation, because we are including the negative 4, it will be a bracket and then negative 4 to positive infinity. So algebraic notation, graphic notation, interval notation. Now, let's do a quick check. And 0 is a number that's in the solution set. So when I plug in 0, it should make the original inequality true. So let's give it a shot. So let x equal 0. So 3 minus 2 times 0 is less than or equal to 11. Remember, we're always going back to the original equation. That, of course, is 0, and 3 is less than or equal to 11. It is true. So our solution set makes the inequality a true statement. Let's do another. So negative 2x minus 4 is greater than, strictly greater than, x plus 5. So we're still going to use those properties of equality, addition property of equality, subtraction property, multiplication property, division property, because our goal is to isolate the variable and then we'll be able to solve the inequality. So my plan is, let's subtract x from both sides, which gives us negative 3x minus 4 greater than 5. And now let's add the 4. So negative 3x is greater than 9. Divide by negative 3. Once again, we're dividing by a negative, so it will flip the inequality sign to strictly less than. 9 is divided by negative 3, that's negative 3. So this is our algebraic notation, our graphic notation. So less than negative 3, so here's 0, negative 3, negative 6. So normally this would be an open circle, that's how we've graphed it before in Algebra 1 and Algebra 2. Shade to the left. So in terms of interval notation, since our answer set is starting at negative infinity, then remember left to right, negative infinity, up to but not including negative 3. So we will bind negative 3 with a parenthesis. And once again, let's choose an answer that will make our inequality true. So let's choose a number that is less than -3. I'm going to go with x equals -10, and I'm anticipating that -10 will make this a true statement because it's in the solution set. So let's plug it in. -2 times -10 minus 4 is greater than -10 plus 5. So follow order of operations here. 20 minus 4 is 16. -10 plus 5 is -5. And yes, indeed, 16 is greater than -5. So our solution set checks. Once again, remember, our answers are all numbers that are less than -3. So this is an infinite set of answers. One last problem. X plus 3 over 4 is greater than or equal to x minus 2 over 3 plus 1/4. So here we have an inequality that is made up of rational expressions. So just like we did in previous sections, if we have fractions, even though they are our friends, we do want them to leave the party as soon as possible. So 4, 3, and 4. These given denominators, the least common denominator is simply going to be 3 times 4. And remember, 3 and 4 are consecutive integers on the number line. Anytime that we have denominators that are consecutive integers, all we can do is multiply them together. And we're going to use that here. We're going to go through and we're going to multiply everything by 12, and that will eliminate the fractions completely. So 4 cancels with the 12 3 times, and now we need to distribute that 3 through those parentheses. So 3x plus 9 is greater than or equal to, the 3 cancels with the 12 4 times, distribute the 4. 4x minus 8. And then lastly, 1/4 of 12 is 3. So goodbye fractions. And now let's look on both the left-hand side and the right-hand side. And there are no like terms on the left, but there are on the right. So let's take the opportunity to combine those like terms. -8 plus 3 is -5. And from here, let's solve for x. -5 and a -9 is a -14. And then finally, 3x minus 4x is -x. And once again, we are dividing by a negative. And when we divide by a negative, we will flip the inequality sign. So moving to the right here, we get x is less than or equal to 14. X is less than or equal to 14. So on the number line, and when you're making a number line, make a number line that just meets your needs. So 13, 14, 15, 16. So less than or equal to 14, normally that would be a solid circle and then shade to the left. So our answers are less than 14. So from here, let's choose a number, and the easiest number that's less than 14 is 0. So I'm going to do my check right over here. Let x equal 0. So when we plug in 0 into the x, into the original inequality, we should get a true statement. So 0 plus 3 is 3/4 greater than or equal to, 0 minus 2 is -2, so -2/3 plus 1/4. Yes, this seems to be true. We will get a common denominator just to be certain. So times 3 times 3 times 4 times 4 times 3 times 3. So 9/12 is that greater than or equal to negative 8/12 plus 3/12? Yes, 9/12 is definitely greater than or equal to negative 5/12. It checks. So last thing that we did not do, we need to put our answer in interval notation. So our solution set starts at negative infinity. Remember, interval notation is all about left to right. So this is negative infinity up to and including 14. So we have the algebraic notation, the graphic notation, and the interval notation. Solving inequalities.